Okay, let's begin. I'd like to welcome everyone to the Senior Capstone Design presentations. This year's project is to develop a parcel of land in Tiverton, Rhode Island. The parcel is located on water and comes with spectacular views. Mark Fisher, who is a URI CVE graduate who has obtained his PE and architectural license and is now the URI representative in managing the construction of the new pharmacy building on campus, is acting as the team's client. He has requested that each team develop the site by including a signature access bridge, a restaurant, retail shops, and an overall design which will draw people to his development. This presentation is the first in a series of 2 presentations. The content in today's presentation represents the work that the students have completed in CVE 497. In the spring, the students will take CVE 498, in which they will complete their designs. The 4 groups will each present in the following order: Rise, ACE, Coastal, and Prestige. Each group will have 20 minutes to present, with 5 minutes for questions. Let's now welcome the first group, Rise.
Do you want the 11 by 17s to look at, or no?
No, that's fine.
Where's that? Tom, can you put our PowerPoint on? And then just start it up. Okay. My name is Ashley Betancourt, and as the project manager of RISE, I'd like to introduce our team, the Rhode Island Student Engineers. At the start of the semester, our client, Mark Fisher, explained to us a site in Tiverton, Rhode Island, which you can see here, which is approximately 5 acres of waterfront property. He just explained how this was a phase 2 of a 2-phase project. Phase 1 being the development of a 55+ active housing community right here, and phase 2 was intended to be the development of a small village, a village of shops and eateries, similar to Newport or Jamestown. He requested that with our design, we have not only a place that people would want to come, but a place with a lot of character. He mentioned the possibility of an iconic bridge, and he definitely wanted free movement throughout the entire site and public access to the waterfront. He requested that we have a restaurant for 75 guests annually, 125 seasonally, and an additional 75 for events. He also wanted dual apartments and shops, 4 to 5 of them, near the waterfront, shops on the first floor, and apartments on the second floor. He also required that we recognize the fact that there is a railroad right-of-way and the possibility of a DOT bike path. Also, we needed access from the other site, from our site, emergency access to the adjacent site. And with this, our team built our plans around the following concepts to meet Mr. Fisher's desires. We would emphasize the land's natural beauty, and we do this by hiding our parking and using the natural topography of the land. We also wanted to maintain a flowing relationship between all the buildings on our site, and we do this through a fluid architectural style. And the last but not least, we wanted to make it a place of year-round activity. And next, Ben Rampone is going to talk about our site layout.
Hi, my name is Ben Rampone. I was responsible for the site plan. There were several things we wanted to keep in mind when designing our site. The first being taking advantage of the existing grades on our site while trying to increase the number of patrons that would visit. The first thing you notice when you enter is our restaurant, which we wanted to be the focal point. Adjacent to our restaurant is an underground garage, which we designed to hide the parking as much as possible. Our site also includes 4 shops with apartments above, an amphitheater for musical acts, as well as a public boat ramp. This is the layout of our shops. We wanted to disturb the coastline as little as possible while staying inside the 100-year flood line. We also included side street parking as well as a lot for the shops. This is a display for public artwork, and we also included a wooden walkway leading down to the waterfront. Again, this is our restaurant, which is the centerpiece of our site. We have a 56-space underground garage. Above the garage is a grassy function area, which leads down to our amphitheater. And these are some design concepts we came up with. When there's no musical acts going on, we have a fountain on the stage, which will bring patrons down to the waterfront with their children and families. And this is a design concept we have for the seating arrangement for the amphitheater. And now Oliver Libby will talk about stormwater.
Hello, I worked on the site civil engineering team, and this is our stormwater management plan. We had two main design concerns. One was to remove all pollutants from road runoff, and two, to allow for some groundwater recharge. We broke our site into 3 sections, each designed to hold around the same capacity. The first section takes the runoff from the entrance road and discharges it into an infiltration basin, which has a riprap overflow spillway to handle any high-intensity rain events. Secondly, for section 2, the road runoff is passed through a storm scepter and directly discharged into Sakonnet River Bay. Storm scepters trap both small and large particles and trap any oil or gas that may be contained in the runoff. For the final section, the parking lot and the road runoff is passed through a storm scepter again and then discharged into a stone trench, which allows for groundwater recharge. Our final concern was the roof runoff polluting the surrounding waters. So all roof runoff is passed through rain gardens, which take advantage of local plants that absorb any harmful nutrients that may be contained in the roof runoff. Jimmy Medina will now be talking about our roadway design.
My name is Jimmy Medina, and I'll be talking about the roadway design. As you approach the site, you enter through a 500-foot roadway segment, which consists of a grade of 7% of 500 feet of asphalt, and which is highlighted in the pink. And as you continue the road in orange, there's a grade of 4.3% of grade of 4 feet of asphalt. And in the green, a grade of 0.5% of 400 feet of asphalt. And we have there are two 20-feet gravel roads, which the blue, which leads to the boat ramp, and if you look at the green, the gray road, and what's in gray, it's the emergency access road. Next slide. Road profile. The first picture is a picture of our road profile. This is a picture of road profile that you have to bring. As you can see, we'll have to bring a significant amount of fill. And on the second one is second picture of the profile. That's a picture of the cross section, and self-explanatory. And about this, we recommend bituminous asphalt binders, which is 3/4 inch stone, and bituminous asphalt top of 3/8 inch stones. We also taking advantage of reclaiming asphalt products. Our road profile, and Sam Jacobs will be talking about the geotech aspect of our presentation.
Hello, my name is Sam Jacobs, and I was part of the geotechnical team for this project. And as a geotechnical engineer, it was our responsibility to study the different soils we had across the site and determine whether or not if they could support our loads from our structures. In terms of our shops, we found that our bottom floor elevation would be 26 feet, and to meet this, we would have to add a layer of fill of 8 feet. And beneath that, we had a pre-existing layer of fill about 10 feet down, which contained inconsistent densities. And from this, we determined that it was inadequate to support our loads. Beneath this was a small natural sand layer containing some silt or gravel, which was then supported by dense glacial till and sandstone or bedrock. From this, the recommended foundations we came up with were to have shallow foundations that would go into the pre-existing layer of fill, which are then supported by deep-driven piles into the dense glacial till. And now Matt Dunn will talk about our foundation recommendations for our underground parking garage and restaurant.
My name is Matt Dunn, and I was the second geotechnical engineer on this project. What you're looking at here is a section of our solar profile DD, which incorporates both our restaurant and our parking garage. Our restaurant has a basement elevation of 13 feet. From that, we determined that we're going to have to take about a foot of fill out of the south side of our restaurant, which is all the way over there, and the north side needs about a foot of fill. Once we do this, we'll have a pre-existing fill layer of about 8 feet with blow counts of 31, which describes the soil as a dense soil. Below this, we'll have 8 to 11 feet of very dense till with blow counts up to 150. Beneath that, we have a layer of decomposed rock, and then followed by sandstone. We believe that the fill is dense enough to support our foundation, so we'll have surface compaction techniques using vibratory rollers, because this is a sand and gravel fill. And we'll have shallow footings in this fill layer just above the water table of 6.5 feet. Our parking garage has a similar situation. It also has an elevation of 13 feet. This will require a foot of fill added on the south end and 2 to 3 feet of fill added on the north end. Below this added fill is 8 feet of pre-existing fill with blow counts of up to 150, which is described as a very dense soil. Below this is 5 feet of very dense sand and gravel, followed by 5 feet of very dense till. We feel that the fill layer in this area is also sufficient enough to support our foundation for our parking garage, so we'll have shallow footings in this fill layer above our water table depth of 5 feet. Now Mohammed will talk about our bridge design.
Hello, my name is Mohammed. I was in charge for the bridge design. The selection of our bridge was made carefully to minimize any redesign and to achieve a well analysis result for next semester. Our bridge is one span continuous, slightly curved, consists of 12 feet lines, 2 and 4 feet shoulders, and 5 feet sidewalk. The type of bridge is concrete and curved I-beam. It got 2 maximum feet reinforced concrete deck, and we made the minimum required I-beam size, which is 10 inches flange and 3/4 inches thickness. Our bridge is designed to consist with geometric requirement of the railroad, such the federal highway limits, requirement for DOT, specification of American Railroads, Engineering and Maintenance of Ways Association, and the criteria established by Amtrak. The code we used for this design, it was HL93, as described in AASHTO LRFD specification. The bridge roadway and sidewalks were designed to AASHTO policy and geometric design and highway and streets. The bridge signature is classic stone veneer and satellite lights posted to match those existing in the deck. And Andrew will talk about the restaurant.
I am Andrew Petrosoric, and I was in charge of designing the restaurant. The restaurant is a 3-story design consisting of a basement connecting to the underground parking garage, a first floor and second floor. The premise of our design was to create a restaurant that used the views of that could give good views of the Sakana River and of the rest of the site. So this was accomplished by creating a restaurant of unusual design that highlighted the viewpoints of the site. The first floor is, as you enter, you'll see our signature spiral staircase, which is also connected to the basement and the third floor. Next to it, you'll see two elevators, one servicing patrons and one servicing employees. They will run from the basement to the third floor as well. It has a total of 150 seats, and 32 of those will be outdoor on the deck for seasonal seating. The second floor is an entertainment venue for patrons. It's meant to be rented out to customers so they can host parties at the restaurant. It contains a bar, a dance floor, and a DJ area. And now Tom Koval will explain the basement and parking garage.
Thanks, Andrew. Hi, I'm Tom Koval, and I will be talking to you about our parking garage. As Ashley and Ben mentioned earlier, our parking garage layout capitalizes on the natural beauty of the landscape by being completely hidden and underground. This also gives restaurant patrons the advantage of a covered parking directly adjacent to the restaurant itself. There are 56 spaces total, designed around a level of service B, with parking spaces over-designing for small vehicles in response to an under-design for larger vehicles. Moving on to the further with the flow, this design also features a prominent entrance to the restaurant itself. Located here and here are doors which are fully handicap accessible, automatic doors. There is also, for aesthetic appeal, a revolving door right here, and patrons can have entry to the top floors through the spiral staircase here and the elevators here. This garage also serves as a service and delivery entrance for the restaurant itself, with flow paths optimized for smooth flow with a minimum of patron-employee interaction. And moving on, here's Adam Booth with our shop and apartment layouts.
I'm Adam Booth. I'm going to be talking a little bit about our shop and apartment buildings on our site. Our site will contain 4 two-story buildings with an area of about 1,900 square feet. For our materials, we want to keep it the same as the restaurant, with the bottom being a crushed stone material, followed by shingles to the top of the first floor, and then the top will be a cedar clapboard type material. You can see we have 2 entrances to the first floor on the shop. The one in the front, which will give access from the parking lot, and the one in the back, which will lead to the boardwalk, which I'll talk about. And our entrance to the apartment is located in the back, kind of secluded from that of the shop, which we want to keep separate. The basic design of our buildings was to give the best view possible to the back of the site, which is to the water. And with that being said, we kept everything on the first floor to the sides, such as the office and storage space. That way, people in the shop they have this big empty space to shop, and they can easily see from the view to the back of the building. We kept the same design goals for the second floor of the apartment. We wanted to give the main rooms, such as like the living room, and we gave the master bedroom the best possible view of the water in the back. And as you can see, we have a deck which spans from the living room to the master bedroom, which allows people to enjoy the view from there as well. To the back side of our buildings will be a boardwalk, which will connect to all the buildings and shops and the restaurant. And it can be utilized as the outdoor seating area or like small function area for the shops. And people just visiting the site it'll give them access to the shops and the restaurant. They can go to the water below, or they can just go on the deck and enjoy the view as well. Now John Hudson's going to talk about sources of wastewater.
Thank you, Adam. Well, to determine our sources of wastewater, we consulted both RIDM's literature and some CRMC to make sure that we were adhering to what we had to. First off is the restaurant area. We figured there was about 3,900 gallons a day that we needed to be able to treat from there. We based that upon 25 gallons per day per seat for dinner patrons and about 10 gallons for bar patrons. Next, we have the restaurants and shop areas. We figured out that was going to be about 2,120 gallons a day. We based that upon a total of 8 bedrooms with 115 gallons a day per bedroom, 2 small food shops at about 500 gallons a day, and also 2 non-food shops at around, I believe it was 100 gallons a day. Finally, we have the pier where we treat wastewater that comes from the boats. And what we did was we contacted several boat owners to figure out how large their wastewater capacity was on their boats. So from that, we accommodated several boats with 80 gallons a day. Let's see. So what we had to do was we needed a location far enough away from the shoreline that we could easily have all the wastewater drained down to that. So at the lower elevation, we have a septic tank that collects wastewater from the shops, the restaurant, and the pier. From there, it goes to a pump. It gets pumped up near our parking lot to a grassy area where we have a leach field, where Keith Wenders will now take over and talk about that.
Thanks, John. Hi, my name is Keith Wenders. Due to the location of the site, we weren't able to connect to a municipal wastewater treatment facility. Therefore, we were forced to treat on site. Our restaurant requires a grease trap, shown there, which just removes the grease from the prepared food and wastewater. Next, everything flows into the septic tank at the lower end of the site and then is pumped to the top of the site. This is because the lower end of the site is too close to the coast and there is poor soil quality conditions. Next, it goes to the denitrification system, which is a biological filter to remove the nitrogen from the wastewater, and the final process is a leach field. For next semester, we are planning to design a solar aquatic system, which is essentially a greenhouse that treats wastewater. This is going to serve as an educational resource for the public and be a draw for the site. And now our project manager, Ashley Betancourt, will wrap things up.
Thank you. So next semester, RISE will be working on finalizing our design, as well as working on calculations. And based upon what you've seen today, we feel that we've not only met the requirements that Mark Fisher laid out for us for the amenities provided, but we've introduced some design concepts of our own that we feel will draw people to our site not only once, but they'll want to return, because you really can't experience it all in one visit. And so we want to thank you for your time, and that's it.
A couple of questions if anybody wants questions. Any questions for this group?
Sure.
Go ahead, John.
For the apartments on the second floor, you only show one stairway. How do they get out?
Emergency access? You mean in an emergency? Mm-hmm. Yes, the windows are large enough to accommodate a fire escape. Not a physical fire escape, but that's what's required by code, I believe, is just a window that is plenty large enough.
So you're going to have a throw-out ladder that they can chuck out the window?
Yes. Residential. And there's also the deck that could serve. There are 2 exits onto the deck. So there are 3 exits, and the deck can also have something like a ladder. And if you need clarification, ask for it.
Yeah, I think you probably should have some sort of positive over chucking the ladder out the window. And that could be stairs off the deck.
It could be easily accommodated.
And I guess, where's the kitchen?
The kitchen?
When you showed the layout of the first floor, I saw a bar and a freezer.
Oh, are you talking about the restaurant?
Yeah.
Oh, now, first you were talking about the apartments, right?
I know, I changed
Okay,
it, so.
okay. So now the restaurant. Where is the what?
Where's the kitchen?
The kitchen is, Andrew, do you want to talk about this?
The kitchen's located at the very bottom. Once you
I didn't see it near the freezer or the bar.
On the first floor.
It's located down at the very bottom.
Oh, I see. Is the freezer located on the same level near that?
It's located for...
The freezer is located in the downstairs service and storage area.
There will also be additional...
So it's not on the same level as the kitchen?
It is not. The storage, the large walk-in storage freezer will be on the first level. There will obviously be freezer, appliances, and refrigerators in the kitchen.
That sounds like a pain in the ass.
Okay, so maybe one more question. I see Chris. So, quick question for Sam and Matt. One of your buildings is on piles, one is on shallow foundations. Why did you decide to go with deep foundations versus shallow foundations?
Well, our shops, below our shops is an inconsistent fill layer. So range from 15 to 45 to 15 again. So we figured that just the easier, just the dry piles is the very dense fill layer that's available.
So you have some confidence that your fill is really dense in one area and maybe not so dense in another area.
That's how we see it. If we were given like further exploration of the site, we suggest test piles around our actual buildings just to prove that the fill is consistent. But for now, we're going to assume that it's consistent in our restaurant and parking garage.
So it looks like your piles then will be fairly short then.
Yeah, we'll be going down about how many feet? About 10 feet, I would say. Yeah.
Really short piles. Just as a general comment, I thought I didn't see a lot of outline slides. So I know you mentioned here are the project goals, and each section said, all right, we've got some goals, but from somebody who's not been involved with the project at all this semester, very hard for me to sort of in real time keep track. And it would have been nice if at the introductory slide for each section, you said, all right, here are our quick goals, and here are the objectives for each of our subtasks. Because I was sort of on the fly trying to figure out, okay, what is the wastewater group supposed to be doing versus the restaurant layout group and all that kind of stuff. So you sort of said it, but it was hard to sort of keep up with it. So outline slides would have been very nice. Okay. All right, thank you. Good job. Can you put them next to my office? Because there's so much of them. I'll take it up. Good. Yeah, go.
You need power? You should use the same computer for everybody.
They can still see you on mine right now, dancing.
I was using it on.
Is the pointer right? This is the next slide.
That's do you have it on a USB? Yeah, you use it. Okay, good. Okay.
Okay, our next group is ACE Engineering.
Good afternoon. I'm Raymond Panetta, and I'm the project manager for ACE. I'm here to talk about the Mount Hope Bay waterfront project. Our client's vision was a restaurant that would serve 75 to 125 patrons, a set of retail shops with apartments above, as well as a signature bridge that will leave visitors with a lasting impression. To get on the site, we start out with our signature bridge. This is at the top, the highest elevation, and will overview the entire site, as well as give a good view of the water. Going down our curved slope, get to our restaurant and our shops. Guests will park in our parking lot, which is conveniently located near these attractions for easy access. Some of our guests may want to take advantage of the waterfront property by utilizing our boat ramp. We have a boat ramp parking down here for their convenience. We have the Skynet River Bay is a beautiful area and it's a great place to live. So we decided to put homes above our retail shops. We have 6 condominiums, each with 2 bedrooms, 1.5 bathrooms, and a balcony overviewing the water. For the visitors as well as the residents, we have a walking path that mirrors the coastline. It would be a great place for exercise and just to relax. Now here's Anna to discuss the groundwork.
Our first challenge with this site was to determine the soil underneath the major structures. Profiles A, B, and C were used to determine the soil underneath the restaurant, shops, and bridge. Under each structure is uncontrolled fill, sand, glacial till, and decomposed rock. The largest issue we came across with the existing soil conditions was the uncontrolled fill because it lacks uniform engineering properties. Section B shows the fill needed for the restaurant, parking, and road. And Section C shows the cut and fill required for the bridge and abutments. Now, Matt will discuss the site civil aspects of the project.
Thank you. Hi, I'm Matt. My job was to design the grading and some of the site civil aspects of the site. Our first constraint when designing the site grading for this site was making sure that all of our structures were above the 100-year floodplain. Our structures over here and over there. To do this, we decided we were going to bring in fill and start construction at elevation 20 by using retaining walls around the shops. Our second constraint was that we had a road coming in with the existing grade of 57 feet. So our bridge, we wanted to keep it straight. We decided to keep the grades starting at 57 feet. Okay. As you can see on the south side of the site, our grading begins at 57 and slopes downward toward the north side of the site. And on the north side of the site, it continues sloping until it reaches an elevation of 10. To deal with surface runoff on the site, we decided we had to deal with surface runoff from the impervious areas on the site. Impervious areas such as the road, the parking area. To do this, we decided to set up catch basins along the road, spaced 200 feet apart, with oil water separators right inside it. This way, the water can flow through concrete pipe directly to a retention pond on the north side of the site. Now, this retention pond is going to be very aesthetically pleasing. Something similar to this. We plan on having a water fountain in it, grassy areas around it where people could just enjoy a nice day and a picnic, you know. Now, John's going to talk about that signature bridge.
Thank you. Hello, everyone. Okay, so incoming traffic to our development will pass over the bridge you see here. It will take them over a rail and bike path right of way owned by the RIDOT. So the dimensions you see here have been designed around this. For the rail, we have the ARIMA 24-foot vertical clearance. Oops. Right here. And the 70-foot span provides a 25-foot safety median between the rail and bike path and another 25-foot safety margin between the rail and the abutment to comply with AASHTO standards. This will be a single-span bridge with a design strength for an HS20 live load. To do that, we'll use 6 W24 by 104 steel beams to support the cast-in-place reinforced concrete deck. It'll be 7.5 inches thick. The road will have 12-foot lanes and 5-foot wide sidewalks for pedestrians. Moving on to the trusses, they will be the signature feature of this bridge. They are uniquely non-symmetrical, have cutouts, and are purposely mirrored opposite of one another. They will be solely for aesthetics and be non-load bearing. In this still to be developed 3D rendering, you can see this is what it will look like in a galvanized steel finish. To tell you about the road leading off the bridge is Jen.
Hi, my name is Jen. The proposed road is 1,350 feet long, and the road and the sidewalk will follow the same dimensions as the bridge, 12 feet for each lane and 5 feet for the sidewalks, which meets all requirements. We choose to make the road out of concrete instead of asphalt. Some benefits of using concrete are that they have a longer service life of 40 years instead of asphalt for 10 years. They need less maintenance if done properly poured. Is resistant to oil spills in vehicles and extreme weather, and also vehicles use 15 to 20% less fuel on concrete roads than asphalt. One of the requirements for our site is to have access to the neighboring community for emergency vehicles. It's over here. The entrance to the emergency road is located to the left after the bridge. It meets the minimum allowable turning radius of 30 feet. There will be a stop sign located on the emergency access road over here. And there's also a stop sign over here for the residents' parking. Along the road, there will be a lamppost located 180 feet apart. The road continues all the way down to the boat ramp, for the boat ramp and the boating parking lot. Since our site is on Type 5 waters, we are allowed to have a public boat ramp. Since our road is going downhill and turning, we decided to make a design speed of 25 miles per hour. To safely make the turn, we needed a radius of 208 feet. Also, the maximum allowable grade for trucks is 8%, so our roads varies from 1 to 7%. Now here's Alex to speak about the parking lot.
Hi, my name is Alex, and I'm here to discuss the parking aspect of our design. Our layout has 3 different parking areas, which include the main parking lot, the street side parking lot, and the dock side parking lot. The parking lot design was developed using the Parking by Eno Foundation for highway traffic control. Here's a small portion of the guidelines that were used. Here you can see the many different dimensions that can be obtained from this chart. Right here you can see the angle of the stall width, the depth of the parking, and how far away each stall has to be from one another. We first come to our main parking lot, which is a large rectangular lot, 51,000 square feet in size. It has 130 stalls, 130 90-degree stalls, including 4 handicap stalls, which meet the minimum requirements. The parking lot is to be used for the restaurant patrons and employees, along with the shop's patrons and employees. There will be a lighting system incorporated in the lot for the safety and convenience of everyone who wishes to use it. The lights are placed strategically throughout the lot, with 2 at the entrance and a few in and around the lot itself. We believe these spots will provide maximum visibility during the nighttime hours. The material for this parking lot, we want to use a crushed stone for both practicality and aesthetics. Along with the crushed stone, we are going to have deep-rooted trees to help encourage infiltration. Next, we have the street side parking. The street side parking is for the use of the residents of the condos. We will be enforcing the parking only for the residents, and we will have signs placed. The side stalls are similar to that of the restaurant parking, but slightly bigger for the convenience of the residents. The material for this lot will be the same as the road, which is concrete, as stated before. And this area will have 9 stalls and 1 handicap stall to meet the minimum requirement. And finally, we have the boat ramp parking, which is for use of any car who wishes to bring a boat on a trailer. The stalls are right here, and they're obviously going to be bigger to accommodate the bigger requirements. They'll be 50 feet deep and 9 feet wide, which we believe is more than enough room for a car carrying a trailer. There are also 5 normal-sized stalls over here. This lot will be the same material as the restaurant parking, which is going to be a crushed stone, and will have similar lighting throughout. And here to talk about the walkway is Thaddeus.
Good afternoon. My name is Thaddeus. We wanted to provide immediate public access to the coastline, and a walkway is the perfect solution. A bonus also to adding this walkway is we are able to build within the 50-foot buffer zone stated by CRMC. Key features, this walkway ties together key features in our site. It connects the restaurant to the pier to the shops. This walkway is over 1,000 feet long and 6 feet wide. It contains 2 turnaround points and 2 sets of stairs. The walkway is fully handicap accessible with its compacted gravel surface similar to the ones in the boat ramp parking lot and the restaurant parking lot. There's a handicap ramp located in between the shops and the pier right here, and that conforms to all ADA restrictions. The walkway will contain lighting structures These lights are on sensors and are solar powered. They turn on at dusk and they turn off at dawn. They will emit a soft light glow due to their solar power source. The path will also contain strategically placed benches down at this turnaround point and trash cans throughout. Now to present our restaurant design is Marshall.
Hi, I'm Marshall Audette. I designed the restaurant. For the location, we wanted it, because it was going to be the main attraction of the site, we wanted it central throughout the site. So we placed it right here. This puts it right near the water and the pier, so that any people traveling by boat can stop, dock up, and come in and grab a bite to eat. We placed it close to the shops here to provide interaction and commerce between the two, being such a short walking distance. To the north side of the restaurant is going to be a large grassy area. This will give the restaurant a place to hold events and things like that. As far as the layout, they are welcomed by a large circular room. Only the finest materials are going to be used throughout the restaurant, and especially in this room. This is going to give a nice welcome and luxurious dining experience. Large circular stairs are going to provide immediate entrance to the upper level, and doors are going to provide entrance to the lower level. The first level is going to be more of a banquet style layout. All the tables are going to be movable so that they can set up a temporary stage or a dance hall for certain banquets such as weddings. The decks can also be placed on the tables can also be set on the deck right here during seasonal events. The kitchen is going to be on the first level here. It's an 1,800 square foot kitchen with immediate access to the upper level with stairs here and immediate access to the deck with a door here. The second level will be more of a fine dining setup. This is going to provide comfortable booths surrounding the corners here, and also a bar. Now, there's going to be a 70 foot by 20 foot glass wall right here. This is going to give the guests the view that they expect when they come to a seaside restaurant or riverside restaurant such as this. There will also be a balcony right here overlooking the first floor from the second floor to give it a more open feel and provide unison throughout the restaurant. There's going to be 8,000 square feet of dining area. This is plenty of room to not only comfortably sit the 125 guests, but also provide room for future expansion of the restaurant. These are some rendered images of the restaurant. This is the front view, the main entrance, and the rear view with the large glass wall. The exterior walls are going to be made of insulated cinder block, and steel joists are going to provide the second floor. It will be covered in a veneer stone facade to give it a classic and elegant look while also giving it a natural feel. The decking is going to be a composite material, so it's very long lasting and just another quality material. Now to talk about the shops is Brian.
Hi, my name is Brian Mahoney, and my responsibility was to design the retail and residential space. The structure is located in the southwestern part of the site, providing immaculate views of the Secundit River. The building is comprised of 3 separate substructures, two of which contain the retail space in the first floor and 3 two-level condominiums above. The 2 substructures containing the retail and residential space are oriented at a 40-degree angle in order to take advantage of the waterfront views. 6 1,300 square foot condominiums will be available for rent or ownership. Each condominium is 2 levels, has 2 bedrooms, 1.5 baths, a balcony, and large windows with water views. Resident swipe cards will be required for access to the condominium lobby, which contains a mailroom and access by stairs to the second level shared deck area and individual resident entries. 2 1,200 square foot retail spaces will be available for lease. Each space has large windows with water views, 2 restrooms, an office and storage area, and an area for utilities for the entire building. Each retail space will have a 500 square foot covered outdoor area with access to the walking paths on the water side. 4 reinforced concrete columns will be used on the water side of each of the 2 main substructures. The structure will have timber framing, stone veneer on the first level, similar to the restaurant, wood siding on the second and third levels, asphalt shingles, glass exterior doors to the retail spaces and condominium lobby. Perhaps one of the most important components of any structure is its foundation. Here's Rich to discuss foundation determination.
Thank you, Brian. Good afternoon. My name is Richard Genovese, and I will be going through the foundation options. A cost analysis was performed on 2 types of foundations. A shallow foundation, which was assumed to have 6 spread footings, along with a continuous footing running along the perimeter of each structure, and a deep foundation, which was assumed to be wooden tapered piles with a capacity of 50 kips per pile. As Anna previously mentioned, there is a layer of uncontrolled fill underneath each structure, which would need to be densified. The primary cost of the shallow foundation is the removal, compaction, and replacement of this fill. Also, for that analysis, the cost of concrete was considered. The deep foundation was assessed only by a cost per foot of pile. As you can see, the shallow foundation is considerably more expensive, and thus our recommendation is to use pile foundation for both the retail and the restaurant structures for 2 reasons. 1, obviously economics, and 2, it will avoid any potential issues associated with the removal of uncontrolled fill. Now to discuss the environmental aspect, here's Joseph.
Thank you. My name is Joe, and I designed the on-site wastewater system. There will be 2 separate systems for our site, first being a restaurant and the other for the condominiums and the retail. The restaurant has a design flow of 5,000 gallons per day with 125 people. And due to the commercial waste that the restaurant generates, a secondary process is needed. This secondary process can be achieved by Advantex treatment systems, by chloroquine systems. This type of system will reduce our leach field by 50%, which with longer retention times and different dispersal agents. With the Advantex system, we have a septic tank of 20,000 gallons, a grease tank of 8,000 gallons, and a leaching area of 3,500 square feet. The other site, the other septic, the condominiums and the retail, has 12 bedrooms and 2 shops, has a design flow of 1,500 gallons per day. It does not need a secondary treatment process, so standard DEM code can be used. With that, we have a septic tank of 4,000 gallons and a leaching area of 2,300 square feet. Ken is going to talk moving. Thank you.
Currently, Tiverton local industries are underutilizing the wonderful coastline in Tiverton. There is not a single waterfront restaurant, nor is there waterfront retail located in Tiverton. And with the new construction of this Conner Road Bridge, there's not even a boat ramp. So we'll be using this fact, along with the beautiful sunsets that the site will be able to provide, in order to attract a lot of patrons to the site. In time, with future expansion possible to the south and around the restaurant, this will become a Tiverton landmark, much like Gray's Ice Cream or Evelyn's Clams. Thank you very much. Any questions?
Questions?
Quick question. I appreciated the cost study you did in the geotechnical component. I wonder, did you look at cost at all in any of the other components, or is that something you plan to do perhaps next semester?
For this project, we weren't really given a precise budget, so this semester we just decided to try to get the foundation and just the inner workings of how everything's going to come together. Possibly next semester we can go into a little more in-depth analysis of the cost of what each component will be.
Okay. And one more thing on your blueprints and so forth. What software do you use for your blueprints?
For these?
Topographics.
We used AutoCAD.
Transportation
not bad idea to use concrete and asphalt in such an area, like a Bellevue Avenue in Newport. But I heard that the life of asphalt pavement is 10 years. Actually, it's not 10 years, it's 20 years. But unfortunately, the state DOT or city and towns, they didn't do a good job in our state. That's why last one is 10 years. The second part is the question is, what kind of design guide I want to use to determine the thickness of concrete pavement? Did you think about it, or did you decide?
We haven't designed for that yet.
Oh,
We're
yeah.
going for next semester to decide the actual amount of thickness for each thing.
The follow-up question is, what's your plan to characterize subgrade soil below pavement? Did you think about, plan, strategy?
Pretty much this part, we just designed how the layers, the placement, and everything. We haven't designed anything like the depth of it and all that stuff yet. That's we're planning on that.
But if you need something, let me know.
Any other questions? Yes. I have a couple comments first. No site location at the beginning, so no idea where the site is. Again, no outline. The first slide, both presentations, it seems to be a nice, really pretty picture, which is nice, but it would have been easy to put some text over that pretty picture to tell us what you're going to talk about today. I don't know, this might be a communication thing, but your presentation didn't follow at all the categories that we were sort of asked to judge. So if I was just a judge coming in here and saying, okay, wastewater, I'm looking for geotech, bridge design, roadway, site, civil, those categories, and it's like, walkway over here, water, something over here. So it's like I'm trying to figure out the subcategories. So very distracting for me, trying to figure out what you guys were supposed to be talking about. So I don't know whether that was your organization or how it, but it wasn't very consistent. Anyway, I just as a quick comment, Rich, I'll talk to you about piles versus being cheaper than shallow footings. That's surprising, and I think maybe you left out some costs in there, but maybe so. I don't know. Anyway, those are my comments. Anyone else? Good, thank you.
The outlines, yeah. John? Can you help me carry this stuff?
Where's it going to?
You guys have a actual professional community. That's yours? Yeah. For the new group? Yes. Okay.
Is that you? You can put your
That tunnel's way bigger than mine.
Is it?
Thank you.
We're ready. We're ready. What?
Okay, our next group will be coastal engineering.
Okay, welcome all and thank you for coming. I'd like to thank Professor Thiem
Russell Morgan and Mr. Fisher for your guidance throughout the semester. And thank you, fellow students, for attending and everybody at home watching. During the month of September, we were approached by Mr. Fisher, the owner of our site, to develop a piece of land in Tiverton, Rhode Island. It's located just here, just north of the Secundit River Bridge, and it's accessed by Schooner Drive off of 138. As you can see here, we have a very comprehensive site plan. Some of the requirements that were asked for by Mr. Fisher is a signature bridge located here, a restaurant here that can house or serve anywhere from 75 to 125 people, and have at least 25 outdoor seats for seasonal seating. And also he required to have 3 to 4 buildings that were 1,500 to 2,000 square feet of retail space with apartments above. So we have that set up here in a European-style village with New England architecture. And without further ado, I'll hand it over to Kathy Tiven, our site civil person on the job.
My name is Katherine Tiven, and I was a site civil engineer for this project. Our current amenities on the site were that we have here a 55 and older condominium community, and along between our site and the community, we have a DOT right-of-way, which we had to incorporate into accommodating to. And we also have the use of a ready-to-use dock right here, and on the side, which is cut off, there's the remnants of a boat ramp, which we could construct on. A couple of requirements that were all our structures had to be brought to 18 feet high for an elevation. However, we also have a velocity zone due to the Coastal Management Resource Council's requirements that we bring it up 1 more foot. So we needed a minimum of 19 feet for our structures. And then our future site grades, we have our bridge starting here, which is at 56 feet, and it comes down to an elevation of 22 feet, which is where our restaurant is located. The bridge, we have a 6.3% grade. Here we are going to have a parking lot, and over here we have a recreation area that we are considered rolling plains, and it ranges from 18 to 16 feet. It will be possible for future construction on it. And then from there, we have the parking lot here and our European-style village here. From there, we roll down to the boat ramp, which will be located here. Overall, our grades move in this direction, so later on we'll add a retention pond here. And I will now pass it on to the geotech team.
Hi, I'm Andrew De Silva. I'm part of the geotech team here. Here's my colleague, Eric Collette. To begin, we had to find out what the makeup of the soil was, so we created cross-sections near our structures, our proposed structures, and used the boring logs given to us by GZA to examine them. The first cross-section goes near the restaurant. Here's a look at it. It shows us where our existing fill is on top of sandy outwash deposits and then glacial till. Below that is the bedrock. The new fill is going to be brought in to bring up to the elevation where the restaurant is. For our foundation, we will be compacting the fill beneath it a little bit by through scarification in the beginning because the soil is very varying. So we're going to scarify it, compact it, bring in new fill in lifts, and put the foundation for our restaurant right on top. Eric's going to go into the rest of the site.
All right, so now we're looking at the soil profiles for the shops. As you can see, there's a few soil profiles taken for the shops. Moving on, you can see soil profile. Once again, similar to the restaurant, we have some new fill sitting on existing fill. Most of the site is all the same. We'll be adding fill. Moving on, we've got some bridge soil profiles right here. I want to focus on GZ22 to GZ20, and we made another one from GZ22 over to GZ19. The next slide. You can see towards the coast, we have some fill, and that will be an issue because, like Andrew mentioned, it's poorly segregated, and it's varying. On the other side, we have some sand and silt, which is also will not serve for the bridge. We'll be taking that out and replacing it with new fill. One more thing I want to mention that we found that was important was in the sandstone, it's very weathered. Something we're looking at right now, and we haven't done any calculations yet, is to do some base grouted piles for the bridge, just due to that weathering of the sandstone. With respect to the foundation, we found where our site is for the restaurant and shops that it definitely is more economically viable to go with a shallow foundation, and we'll be running some more calculations on that in phase 2 this spring. Moving on to Dave with some more about the bridge.
Okay, so one of the requirements asked for by the owner was that we create a signature bridge. We do that by making the bridge a massive structure. It's going to start up at about an elevation of 60 feet up towards Schooner Drive. We're going to build up 2 retaining walls, fill the retaining walls with fill, and lay our road surface on top of that. And that's going to happen also on the western side of the bridge. There'll be 2 retaining walls that eventually bring the bridge down to grade. The main span of our bridge is going to be consisting of 8 28 by 14 W-beams that will sit on abutments, and these abutments will sit on top of the grouted piles that Eric just mentioned. In order to make our bridge more aesthetically pleasing, we're adding a concrete archway. It's strictly a facade. There's no structural component to this archway, but it will tie our bridge, make our bridge look much more pleasing. And one final characteristic to our bridge are these 4 viewing platforms that we have. Because the bridge is the highest point in our site, we wanted to offer great views from it. So we put in these 4 viewing platforms in which we can put benches and those pay-for binoculars where people can look out and see the entire Seconic River and our entire site. And so now I'll hand it over to one of our transportation workers, Joe Ritchie.
Hi, I'm Joe. I'm part of the transportation team. Our road begins after the bridge at 57 feet elevation, and our radius here is 85 feet. We had to get our elevation down to 22 feet for our crosswalk, which gave us a slope of 6%. Originally, we were going to have our access road come around the parking lot, go under the bridge, and access the houses from there, but we found out that the 8%, it would be greater than 8%, and the fire trucks would not be able to make that, so we put it right after the bridge. From here, our road goes from 22 feet, slopes down, drains into our retaining pond, and goes down to 14 feet here. It gives us a gradual slope of 1% along this road, and after this, our road leads to the boat ramp, which Kevin will talk about.
Hi, my name's Kevin Robenheimer. I'm also part of the transportation team. I worked on the boat ramp design. We designed the boat ramp to provide public access for the typical recreational boat. The roadway has 2 lanes leading down to it, which totals 25 feet in width. The roundabout on the bottom and the bend on the top have a 40-foot radius for turning, which was the minimum requirement. I also have 5 parking spots on the side of the roadway for the boat and trailer parking. These spots, well, each individual spot exceeds the minimum for boat and trailer parking. The boat ramp is actually a concrete slab. It has a slope of 13.5%, which is within the requirement of 12 to 15%. It also extends to a depth of 5 feet, which is needed for boats to be launched properly. The roadway design for our site is pretty traditional. It consists of 5 layers. The only difference for our roadway comes at the boat ramp section. The top 2 layers are porous asphalt as opposed to pervious asphalt as opposed to impervious asphalt. And as I said before, the boat ramp is a concrete slab, which is 6 inches thick, 37 feet long, and 25 feet wide. This leads to Adam, who will be talking about the restaurant.
The restaurant is a standalone structure on the south end of the site. So we used traditional New England architecture, salt box roof, and then we added the shed dormer on the front to give some natural light. And then if we move to the back side, we added this bump out bay window for some shape. And this is our kitchen area over here with the hip roof, and we thought that this would be an ideal space for our HVAC equipment. The inside floor plan, we based this off of, if you're going to have an ocean view restaurant, you want to optimize ocean view for all the patrons. So we have a split level And you enter at the middle level, and then this is a 42-inch half wall here, and there's a handicap ramp, 18-inch drop to the bottom seating level, and then stair access to the top seating level. There's also access by elevator, and the entire structure is fully ADA compliant. This is just a 3D rendering of the restaurant. Just to give you a better idea, there's the entrance, upstairs seating, there's the handicap ramp down, the outdoor seating is over here, and the elevator is over here, and this leads to the kitchen, also the kitchen over here, and 2 restrooms. And I'll hand off to Christina, she'll talk about the shops.
Hi, I'm Christina. I'm one of the structural engineers on our team. We have 3 different building styles in our retail area. The first one we have is 30 by 24 feet. It has an apartment on top, which we view as ideal for where artists could live and sell their work on the bottom floor. There are 3 of these buildings located closest to the waterfront, and they all have decks with views of the water. The second style we have is 70 by 30 feet. It has 1 large retail space on the bottom with 2 apartments on top, each with 1 bedroom. They have access to their own decks with access from the main bedroom and the living area. There's also a porch on the bottom floor where patrons can sit and look at the views. The third style we have is 50 by 40 feet. It has a tiered apartment on top which measures 38 by 28 feet. It includes 2 balconies, one from the master bedroom and one from the living area. And since it is the most centrally located building in the retail area, it has the most prominent architecture. This is the layout of our village area. We have the 2 70 by 30 foot buildings here, the 50 by 40 foot building here, and the 3 24 by 30 foot buildings here. We designed our layout of this area to really bring patrons through it rather than just passing by it. We have a lot of area for them to walk around and enjoy the view. We also define the area with cobblestone pavement beneath it and a fountain here, as well as a wooden windmill here, which Adam will tell you more about.
Dave mentioned earlier that the bridge was a signature component of the south end. We also wanted to have a signature component of the north end. So we created this windmill, which doubles as our required public restroom. It's going to offer a commanding view of the site, just like the bridge does. And it's also going to block out the cooling towers, which would consider an eyesore to much of Tiverton. And if we go to the floor plan, the first floor is the men and women's restroom, and we have elevator access to all floors, secondary access by stairwell, exterior stairwell to the 2nd floor, and then spiral staircase to the 3rd floor. And Mike's going to talk about parking lots.
Hi, my name is Mike. I was also part of the structural team, but today I'll be talking about the parking lots. We have the 2 parking lots. This one's for the restaurant. Both parking lots are designed to Tiverton municipal codes and ADA standards. With the Tiverton municipal codes, you need 1 parking space for every 4 patrons at the restaurant. And then we also put 1 in for every employee. So that equaled out to about 58 parking spots, which we over-designed for to 99 for hopefully if we put in other stuff later, such as fish markets or a marina. And then our restaurant, and then our village parking lot, for Tiverton municipal codes, we need 1 space for every 300 square feet of retail and 1.5 spaces for every residence, which came out to be 38 parking spots. We over-designed this for 55 in hopes that our village will bring a lot more patrons to go see it, and we'll give them the parking spot needed. And both of these parking lots are designed with pervious asphalt to cut down on the stormwater outflow, which John will talk more about.
All right, my name is John Brito, and I was the environmental engineer for this project. For the environmental portion, we had 2 things to worry about: surface water control and wastewater control. So with the surface water, we had to design a detention pond, have runoff directions, and also design for 10 to 20-year storms. For the wastewater, we had to choose whether or not it was going to be on-site or off-site, design the tanks, design the pump station, and also have a connection line. This is going to be our proposed connection line. It's going to connect to 138 right here. All right, first with stormwater management. We have pervious and impervious. We decided to keep the amount of impervious to a minimum, and we did this, and we kept it to about 100,000 square feet. Some of the impervious structure surfaces was the transportation, which was roads and sidewalks, the building roofs, and also the restaurant roof. The pervious area was about 500,000 square feet, and this accounted to a total runoff of about 30,000 inches based on 4 inches of annual of monthly rainfall. Next up, we had the runoff direction. So based on our grades, the surface water is going to run off into this location. And we're going to have a detention pond right here, which will catch the runoff. The detention pond will have non-invasive plants, which will capture the total suspended solids and also some of the contaminants. As well as the diameter of our pond is about 100 feet with 4 foot of depth and a 7-foot freeboard. Next, we had to do risk management, so we designed for 10 and 20-year storms. We have an emergency spillway located right here, which will go down into the trench, and based on the road grade, flow down into the river, so our site will not flood. After that, we had wastewater. So we had to find the sources. The total wastewater capacity was about 6,000 gallons, and our largest source was coming from our restaurant. So we had to design a grease tank. Our grease tank will be located next to the restaurant and will allow the water to sit for about 24 hours until it's gravity fed down to our holding tank. Our holding tank is located next to our retention pond as well as our pump station. Our holding tank will have a capacity of about 30,000 gallons based on DEM standards. Our pump station will also be a two-pump system, and also have a backup generator in case any power outages. So next up, we had to design our connection line. So I contacted the Town of Tiverton Public Works and spoke with the wastewater manager there, John Lincourt, and he told us that there's a connection line at 138, which we could connect to with about an 8-inch connection line, and the length of the line will be about 2,000 feet. So next we'll have Dave, who will wrap everything up.
So as you can see, we have a very comprehensive plan that will serve the needs that our owner asked for. We have this recreation area here, which is ready for expansion. So when we find out that our site actually attracts more people and requires more retail space and everything, we'll be able to expand into this area. Also, there was talk of possibly an inn going in, and there's also plenty of room over here by the restaurant to add the inn there. In conclusion, I'd like to thank my team for great work and a lot of hard work done this semester. Any questions?
Can you talk a little more about your waterfront?
The waterfront is going to be pretty much at grade. I believe it's 10 feet from the water, and we're just going to have a path that stretches around. There's going to be a staircase here and a handicap accessible ramp. The little circles on the map are lights, so the paths will be well lit. And we have a little turnaround over here where people can sit and on benches and such.
And the sawtooth?
The sawtooth is it's to designate a hill. We're gonna have a rolling hill right there that gently leads down into the down to that grade.
And Boatwood Trailer pulls into your roundabout flow traffic. Facing the wrong way at one point.
Yeah, well, we were figuring they turn around and then back down the ramp. How far? This is 200 feet. Mm.
Since nobody asked, I was curious. You have liked to have a windmill, but you said it was only for aesthetic decoration purpose. But now, as you know, we are facing the serious energy crisis. So maybe that can be related to some energy, or if not, like a solar house, or like green building, etc.
Well, we were considering making the windmill operational. We'll check into it next semester about clearances for the spinning blades and having it so close to people walking around. But if we find out that it is that all the blades and everything will be a safe enough distance away from everybody. We'll probably make it an operational windmill to provide some sort of power for. Yeah.
That's right, because this is only one semester. Next semester you have a specific detailed design.
Yeah.
So it may not be a bad idea to think about, consider the how we can have energy friendly or environmental friendly building and infrastructure. Develop.
Is the ramp that we were talking about for the boats?
Yes.
Is that pervious pavement?
Yes.
Boaters are slobs. Well,
Okay.
And they dump fluids all over the place. Some, I don't know, will CRMC let you do that? Pervious pavement.
Okay.
The DEM lets you do that.
That will be something we have to look into next semester, and we have plenty of space over here, so we could possibly put some sort of treatment there that will treat that runoff water.
Now, you have a restaurant, shops, condominiums, a lot of architecture. Did you get any architecture help, or you did by yourself? Match the layout, etc.?
Yeah, we pretty much did it by ourselves. We have some pretty good artists on our crew, and they came up with some really nice renderings. And we used Google SketchUp to make the actual renderings. They have a large selection of textures and surfaces that you can use to make it look good.
I watch a lot of home and gardening channels, so I contributed a little bit, and there were some regulations that weren't even mentioned that I learned from house hunters and stuff like that.
That's good. No other? Good, thank you.
This is the magnitude. Now the remote, I don't know.
Yeah,
Right to the man. Oh yeah, we tried it earlier. Yes.
Yeah, should be all good. Yeah, picture works. All set.
Okay, our last group is Prestige Worldwide. They look pretty uniform. I like that.
Thank you.
Someone made a comment though that you guys should have the same, and girls should have the same type of tie. But,
we want a little variety. It gives us a little personality. All right. I'm Jeremy Henry, and I'm the project manager for Prestige Worldwide, and this is our presentation for Secundant Landing. The location is where this arrow shows is in Tiverton, Rhode Island. It's all through. It runs through the coastline, and this is there's a nice river that feeds salt water. This is a shot that looks towards the site. This, as you might see in the background, there's existing townhouses that we're trying to correlate with the site so that residents that are in the townhouses can walk down to this site that we're developing. This is a shot from the existing pier looking north, so this might be a potential view that you could see from the restaurant and other parts of the location of the site, maybe down throughout the walkway. So some of the top goals that we worked with throughout the semester and that we had heard from the client that we were working with was a real restaurant that admired the scenery, and along with shops and apartments that really just looked at the nice scenery that we have at this site. Another thing that we were really working around was accessibility for the general public and for emergency purposes, and just to have a recreational area and having the ability of hosting of events such as weddings and such forth. Some of the obstructions and requirements that we had to deal with when designing, the main one that we had is the Rhode Island Department of Transportation has a right-of-way that crosses through the entire site, and it's for potential railroad and bike paths. So we had to create a bridge that passes over it, just so that because we can't touch the state right away. Another thing that we had to work around was the floodplain, because we're so close to the water, that we had to make sure that buildings and structures and such forth were above floodplain, including the grading plan was a major obstacle, and the CRMC setbacks.
I'm Pat Lyons. I was in charge of the site civil layout for our project. As Jeremy said, we really wanted to make our site a destination, not only for the people that live in the townhouses, but also the general public of Rhode Island. So some of the key features to our site was at the southern end is the entrance where our bridge will be constructed. As the road slopes down towards the front of the site, there will be a turnoff for the valet parking and an access road for deliveries to the restaurant. That's also where our restaurant is located, right on the waterfront, so it has the best view of the river. The road then continues towards the back of the site, where our main parking lot is located. That will be used for the restaurant and shop patrons, along with the restaurant employees, and anyone who comes to use our recreational field, which will have picnic tables, and it's the location of our detention pond that families can come and have picnics. The road then continues towards the north end of the site, where our boat ramp will be located, and the boat ramp parking lot, and our public restroom. There's 3 smaller structures located on the south end. Each of those include 2 shops on the first floor and 2 apartments on the second floor. There's also a back parking lot, which will be set aside for the tenants of the apartments and shop employees. In front of the shops is an outdoor market area, which includes a stage for outdoor bands and a fountain and area for seasonal vendors to set up shop. Finally, there's a pier and marina area that we're going to utilize for boaters to come and dock up and use our restaurant and the rest of the site. Also, a walkway that connects all these features that includes benches and gazebos along it where people can stop and enjoy the site. And now Tim's going to talk about the grading.
Hello everybody, I'm Tim Bachers. I'm also site civil. I'll be talking about the grading. As you can see, there's 2 different lines. Well, there's a lot of different lines, but main ones are the red ones that you can see is the existing, and while the blacker ones are what we're going to do for proposed. There's 2 retaining walls we're going to put in, as you can see, depicting. The one on the left is where the road will be following. That will be able to maintain the 8% grade as per requirements, and the other one will also let us have the whole complex of the restaurant here and the shops here get the same kind of elevation. They both need to be put up to the flood plain, so we brought that up. The basements for the restaurant and the bottom floor for the shops. The parking lot did not need to be above the floodplain, so we used it over here, and the whole site for our proposed grading will go from the southwest and northeast for stormwater flow, and all other things. Right up here at the top is going straight down to where our walkway will be. It's significantly lower than the restaurant itself, so it does not mess with the view for the restaurant. And also at a dark line here, you can kind of see where the 15 is. That's the setback from the CRMC. We couldn't touch it. And one of those things, make sure that we don't do anything for it. Along the walkway, there will be some plants there with another scenic view on it. Here's Allison. She's up next.
Hi, my name is Allison Drake. I am part of the environmental team. The flow demands designed for the site were dependent upon the best and busiest time of year, which is summer, because the marina and the outside deck to the restaurant are in use. For the flow demands, we found flows for the restaurant, the shops, the apartments, public restrooms, and the marina, which totaled out to be 10,150 gallons per day. We decided to pump our wastewater off the site to a wastewater treatment plant in Fall River. The pump is located at the public restrooms, which has the lowest elevation point on the site, which helps it, which means the wastewater is aided by gravity.
My name is Joe Sandor. I'm also with the environmental, and the restaurant requires a grease trap, and we have here a preliminary design of the grease trap, and it will be required to be a minimum capacity of 1,000 gallons per DEM requirements. For the stormwater, we have the entrance road and the small parking lot behind the shops and apartments of impervious material with catch basins, and the stormwater will flow through a pipe underneath the recreation field to a detention pond where it will be slowly treated and released into the Sakonnet River. The boat ramp access road will be pervious material, as well as a large parking lot totaling to an area of 31,000 square feet.
As you can see on the schematic, by the black looking line is the wastewater, where all three shops and the restaurant tie into one main line that travels from the main road down to the back road to where the boat ramp is, and here are the public restrooms. This is, as you can tell by the contour lines, the lowest point in elevation. From here where the pump is located, it will be pumped up towards 138 and then up to the wastewater treatment plant in Fall River.
For the stormwater, you can see that in the dark blue lines, it will follow the road here, and also from the small parking lot to here, at this central point where a pipe will run under the recreation field to the detention pond. The water is treated and then slowly released into the river. And you can see the large parking lot and this boat access road are of pervious material and will not require additional treatment.
Thank you, Joe and Allison. Hello, I am Matthew Carmody, and this is my colleague Aaron Pike, and we are the geotechnical engineers for this job.
That just said, my name's Aaron, and as our first step as geotechnical engineers, we need to determine the type of soil that we'd be working with. So, with the provided boring logs, we were able to obtain 4 cross-sectional areas. These are the blue dashed lines seen on the screen. Our most important cross-section area was our first cross-section. This sits under a proposed restaurant and also where our shops would be located. The soil that we found the soil consists mainly of, because of its close proximity to the water, it's mainly composed of fill. So the fill layer is ranging anywhere from 20 to 10 feet, mainly larger, closer to the water, kind of decreasing as it moves east. Underneath the fill is a layer of glacial till, and then underneath that is a more dense layer of bedrock. There it is. The shops that were located on the east end, because they were more composed of a denser soil, we can use shallow spread footing foundations. But as for the restaurant, which is located more towards the water side of the site, we're also going to have to bring in a lot of fill, so we're proposing that we use piles underneath the foundations to make sure that we ensure that it's a solid foundation for the restaurant.
Due to the large change in elevation throughout the site, we found retaining walls are needed in 4 main locations. The first location was near the bridge. For the bridge, use a cantilever retaining wall, as seen here. The height of this retaining wall will be a total of 35 feet, with the base footing being 25. The ground level will be 10 feet. It will be 10 feet below the ground level. This will be made of concrete, the entire thing, with a drainage down here in the corner. The next retaining wall needed was a reinforced earth retaining wall. This is right off the bridge, as you can see here in this example, going down around the road. The max height needed for this will be 25 feet and will be dropping a slope throughout the site. This will be made with a concrete slab in the front with galvanized steel ties going into the earth. For the maximum height, as I said, is 25, so the max tie length will be 40. These have been calculated. The other 2 main locations that these retaining walls we needed, we decided to go with gravity and rip-wrap retaining walls. Locations here, it will be right down there on the sidewalk near the parking lot, and it will be a max of 5 feet. Also in front of the restaurant, which is a max of 15 feet. We feel that this will give it a nice New England style look, along with near the lighthouse to give you that authentic lighthouse look going up. Other things I forgot to state before were for the earth reinforcement retaining wall and the cantilever. It was calculated for safety factors against overturning, sliding, and bearing capacity.
And now on to our transportation.
My name is Chris Elmer, and I was one of the transportation engineers. As Jeremy said, one problem we had was that our site needed 2 emergency exits for emergency vehicles. As you can see here, there was an existing grave road, which is on the site, adjacent to our site. Just over the bridge, we had no problem tying into that road because we did not need to bring much material here, so they're the same elevations. As the road comes down, this whole portion of the road and back parking lot will be paved and impervious, whereas the large parking lot and the boat ramp lot and the back road will all be pervious material. As far as the entrance road, we designed it for a 2-inch bituminous surface course, a 6-inch bituminous base course, and 12 inches of a processed gravel subbase. The entrance road had a max 8% grade with a 2% grade from the center line to the gutters to relocate the water to the proper drainage structures. As far as the curbing and sidewalk, the sidewalks are designed with 4-inch Class A concrete with 24-inch processed gravel subbase, and the curbing is a precast Class XX concrete, and the curbs are designed with a 6-inch curb reveal. Here's just a cross-section of the road just showing the 12-foot lanes with a 5-foot sidewalks and 6-inch curb reveal, and the 2% grade.
I'm Ricky. I'm also with transportation. And for the back road and the access road to the boat ramp, we used a pervious material. We decided to use crushed seashells for a beachy look, and we have 6 inches of that, 24 inches of processed gravel subbase, and then a 3% grade from the center line to the shoulder, and a 4% grade from the shoulder to the gutter. We have a drainage swale on the left side of the road and additional parking on the right side. This is a cross-section of the pervious, and we have 10-foot lanes with a 2-foot shoulder, and on the left you can see the drainage swale, and right is additional parking. For our parking lots, we have the large parking lot design, and Tiverton requires 1 spot per 4 patrons. So we had the large parking lot, a total of 83 cars, plus 9 spots for overflow, which gave us 92 spots. For the shop owner and tenants lot, we have a total of 12 spots. And the boat launch lot, the client asked for 5 spots, but we also have additional room so that the boat trailers can turn around. And then we have the additional dirt lot for boat trailers.
Hi, my name is Vincent Palladino. I was a structural engineer and involved in the bridge design. We designed this bridge for the Rhode Island Department of Transportation general specifications for a bridge. The west end will have a fixed type 1 abutment back wall, and the east end will have a expansion joint with a strip seal. So with the seasons and the changing temperatures, it can expand. It will have a stone facade that will have no structural purpose at all, and it will just show its unique New England style. And at the entrance of the bridge, there will be a little plaque that has the title of the development, and it will show a nice entrance to the project. Okay, this is a cross-sectional view of the bridge. It will have 5 W24 by 104 steel beams running east to west down the bridge. And it will be spaced at 5.5 feet each apart. There will be 2 lanes, 1 in each direction at 12 foot wide and 5-foot sidewalks. The sidewalks will be separated from the road with 2-bar wood bridge rails to separate the vehicular traffic and the pedestrians walking on the sidewalk. And now Henry Cotta will be talking about the shops.
Hi, like Vinny just said, my name is Henry Cotta. I was also on the structural design portion of the this project, and I'll be talking about the shops. From left to right, you can see the front, rear, left corner and right corner of the shops and apartments on the second floor. Kind of going to go through a 3D tour of the interior of the apartment. The entrance for the apartments are in the back. This is coming in through the rear entrance right now, coming up the stairwell. Looking down, you can see to the left there's a bathroom and then an office area and a washer and dryer area. Moving down, this is the kitchen area with a walk-in pantry, fully equipped with a fridge, microwave, stove, bar area with stools. This is the dining room area and the living room area, and on the left there's a deck looking out towards the water. Here's the bathroom. And this is the guest bedroom. This is followed by the master bedroom. And the deck outside facing towards the water. We situated the buildings northwest to give the maximum possible view of the water, as well as the Secundit River Bridge. And we designed them to be approximately 1,500 square feet. We designed 3 separate buildings, but we're only going to, as of right now, we're told only 1 is going to be occupied. Shown here is a floor plan. To the left is the shop. There's a rear entrance in the back for the shopkeeper. To the left over here is the office area, stairwell up to the apartment. Storage area here with a bathroom located here for anybody in the shop or working there, and this is the break room area. And this area we left empty just for the shopkeeper's discretion. And like I said before, this is the second floor plan, and I already took you through the tour, so you know about that. And Dean is going to talk to you about the restaurant. Hi, I'm Dean Figueroa. I was also on the structural team. I'm going to talk about the restaurant. The client's goals for the restaurant were to seat 75 to 100 people in the winter and an additional 25 in the summer. He wanted to optimize the views, taking advantage of the waterfront and the Secundit River Bridge. And he wanted it to be aesthetically pleasing. He wanted to make it a destination spot where people would be attracted to come to, spend their time and money here. And here's our actual, what we were able to accommodate. We were able to accommodate 104 seats plus 8 bar stools in the winter, and then 132 plus 14 bar stools in the summer. The location of the restaurant is near the water. The water is over here, and there's a giant wall of windows for everyone eating in the restaurant. They have a good view, and both decks are also situated facing the waterfront. Right here is where the bar is. There's inside and outside bar seating. The restaurant will be situated above the flood, above the buffer zone and all the plants, so the view will not be blocked. The main entrance here is distinguished and near the road, so they're easy drop-off. And the back door operations, which you wanted hidden, are down here on the side on the basement floor, with the staircase here leading into the kitchen area. And then here's some 3D renderings of the shop. This is looking at the front left side. Here's the entrance here, and then there's another door here, for they can host weddings over here, and then there's a deck leading into the restaurant. And here's the right side with the delivery and the garbage area down here. This is another door for anyone coming off the boat ramp or the dock. They want to come in, they can come in through this way. The bar is right here. There's the bar from the outside. This is the seating area, and there's some seating outside here. There's actually a stairwell in here leading up to the top. There'll be a lounge where you can look out and get a better view. I'll show you that in a minute. This is what the front looks like. Proposed name, the light. Some more views of this. And the inside, there'll be booths. 4 people for table seating, and then 2 people seating over here. The outside deck with the bar and some seating here, and the upstairs lounge with a lookout of the views. Back to Jeremy.
So to conclude our presentation and our project, we felt that we've met all the goals that we were set for and all the tasks that we were asked to do, and for next semester we're planning on finalizing the designs and making sure everything is set properly, and to move forward and be able to complete the designs and plans. We also, throughout our designs, we introduced some of our own concepts and our own plans to add to the developer, really to utilize and the views, and we also made sure that we had emergency access. And we, throughout our ideas, we also tried to make sure that things were cost effective, whether it was minimizing fill or just basic material selections. So if you have any questions, please feel free.
Your bridge drawing shows 7 beams, but your explanation of it said there were 5.
Yes. The RIDOT general bridge specification had 5, but we drew in 7. So I guess
We also haven't completed the final designs. Right now, it's just a basic concept. We're still having to go through the designs and making sure everything's the way we want it. As of right now, we just use a basic load that we estimated, and we just were more worried about the layout of the entire site and project for this semester. Next semester, we were definitely going to go into more detail about beams and such forth and supports. Any more questions? Yeah, Professor?
Yeah. Very interesting. However, some of them have already detailed. And in a short period, I was wondering how you come up with those details. For instance, like asphalt pavement, you have already thickness. But you did not say anything how you decide or how do you determine the thickness, or what kind of design guide you use. It's not there. I rather want to have it at this stage, okay? Like what kind of condition they have, like a sublet soil, what kind of traffic we are talking about, what kind of material is available. So, we are going to design this way. That might be more comfortable to me. Okay. Same thing for the bridge. It's already there detailed. And then, there are not much like the background on those things. Okay. So I don't know which stage you are here now, but that's a little questionable to me. Can anybody address?
Well, we have preliminary designs for now, but things throughout, whether it's road designs and layers and materials or bridge structures in the buildings, is all preliminary right now. We're going to go back and make sure everything is the way we want it, and going back into designing everything, whether it's beams or layers of materials. but I know Chris was the main designer for the road designs, and
as far as the road designs and thickness, they just went based on a standard design for new construction, and because the material underneath the road is questionable, that's why we proposed to have like a 12-inch process gravel, that we're going to bring in sub-base for the road.
In such a case, my question is, what standard you are talking about?
Rhode Island DOT standards.
Rhode Island DOT standard, and then that road is not state maintained roads, right?
Well, that would be private.
So, in some sense, you are just copying something. That's not the engineer supposed to do. I hope, okay, you can have some sort of basis. Why we need a 12 inch? The sole base layer. Why we need a 6-inch as part of the base? Why we need to have a 2 inch? Without knowing, just copying something.
Yeah, that's something that we're working on next semester for sure, is going through it all. But right now, we just wanted to present something so we had a basic idea. We know that the DOT standards aren't going to be the right standards for this privately owned project and site, but we just want to have something to present to show kind of a rough idea of how it was. None of these numbers that we presented today are set in stone, and we're planning on going through and coming up with our own designs and specifications for sure.
It's understandable.
Okay.
But the way you present was kind of, I need some sort of more engineering basis.
Okay.
That's why only I'm hoping.
Okay. Yeah.
That doesn't mean, it's good job, you guys. It's very good job. But I think I'd rather have some sort of a basis, engineering criteria.
Okay.
Those kind of things you can tell us. I'll be more comfortable.
All right. I would definitely look for that next semester.
Thank you.
Thanks. Okay, let me just thank some of the people, the unseen people and the seen people that helped on this project and helped guide the students. Russ Morgan is co-taught this course from GZA, and he's been just amazing in terms of the amount of time he's devoted and the resources from GZA that's really helped us. He's helped us in academics to expose the students to more practical engineering designs. Mark Fisher, thanks Russ. Mark Fisher has been a pleasure to work with because he was able to put on his architect's hat and he was able to advise you, all of the students, in terms of maybe more of an architectural feel or an owner feel, like what would you like, what would he like as an owner? And I think that lent a lot of authenticity to some of the work that they were doing. So thanks a lot for giving us your time. Some of the other the team leaders put a lot of effort, and they had a lot of stress. Can you imagine trying to get 12 or so individuals to perform at all times? So I think we owe them a round of applause. A couple other people in the background, George Ciatis helped us a lot with the computer, so I think that one. Also in terms of, wait a minute, also in terms of structures, how many times have you come into his office and said, in effect, I want to design a bridge, and then he would ask, okay, well, what's the length of it? What's the span? Well, I'm not sure. What's the width? Well, I'm not sure, and treated you with respect rather than just, booting you. So thanks, George, for helping us on that. And finally, although you can't see him back there, Randy Stevenson has set up this web podcast, which is our first and hopefully not the last. So thank you, Randy, for doing this for us. Okay, this concludes our presentation, and hopefully we'll see you. We'll see you in the spring with more design details. Thank you for coming.